In this lesson, we want to learn about inverse tangent function. Tangent function is not one-to-one, so we limit ourselves to the region where tangent function is one-to-one, nearby y-axis. So we choose from minus pi over 2 to pi over 2. If we think about the quadrant involved, then minus pi over 2 to 0 is quadrant 4, and 0 to pi over 2 is quadrant 1. If we visualize the angle location in the quadrant, then that'll be here, either in the first quadrant or fourth quadrant. This is quadrant 1 and this is quadrant 4. What I said was we define an inverse tangent function on minus pi over 2 to pi over 2. This time, we don't put minus pi over 2 to pi over 2. So we use parentheses because those are asymptotes, vertical asymptotes, and none of the tangent function is not defined there. Notation of the inverse tangent function of x is y equals tangent inverse of x. Again, that is not 1 over tangent of x. That came from tangent of x to the 1 power. This is inverse tangent function of x. Sometimes we write it down as ARC-TAN, arc tangent function of x. That is equivalent to inverse tangent function. Y equals tangent inverse of x means tangent of y equals x, meaning input of the tangent function became an output, and output of the tangent function became an input. So y is the angle in minus pi over 2 to pi over 2. Range of the inverse tangent function comes from the domain of the tangent function where that was 1-to-1. We limited ourselves from minus pi over 2 to pi over 2. This x value became an y value, and that became the range of the tangent function. Domain of inverse tangent function came from the range of tangent function because we are changing x and y. So that becomes minus infinity to infinity. So we are talking about this aspect. Before we graph the inverse tangent function, we want to do some observation. Graph of inverse tangent function. We will consider the tangent function from minus pi over 2 to pi over 2. We know the graph looks like this. Our strategy will be switching x to y and y to x. There is an asymptotic property. Do the asymptote where x equals pi over 2. And for this asymptote is x equals minus pi over 2. When we describe this, we can say as x approaches pi over 2, this arrow means x approaches pi over 2, y goes to infinity, it diverges. For this part, we can describe that as x goes to minus pi over 2, y diverges to negative infinity, falls forever. For this, that means tangent of 0 equals 0. Based on this observation, and by switching x and y value, we will graph the inverse tangent functions graph. Y equals tangent inverse of x. What I said was when we make an inverse function, we switch x and y. So x equals pi over 2 will become y equals pi over 2. So this time, instead of vertical line, we are getting a horizontal line. This is y equals pi over 2. So this point is pi over 2. And this vertical line will become a horizontal line that becomes y equals minus pi over 2. This value is minus pi over 2. Those were asymptotes, so we will convert this asymptote to horizontally. So as x goes to pi over 2, will become y goes to pi over 2 as x goes to infinity. Let's write down. As x goes to infinity, y goes to pi over 2. So y became x, x became y. Tangent of 0 equals 0 even when you switch input and output, we get the same conclusion. Tangent inverse of 0 becomes 0. As x goes to infinity means when we follow the graph to the right, y value will approach pi over 2. The only way that can happen will be when the graph changes this way. And for this part, we can say that as x goes to minus infinity, y will approach minus pi over 2. So y became x, x became y. And this is an asymptote, and x value stayed negative here, so y value will stay negative here in the inverse function. So the only way that can happen will be when the graph changes in this way. Let's do some examples. Find the exact value. If it is defined, the first problem is tangent inverse of minus 1. Let's just follow through the definition of inverse function. Tangent inverse of minus 1 equals theta. We were thinking about minus pi over 2 to pi over 2. That's equivalent to say that tangent of theta equals minus 1 by using the original definition of tangent. That means minus 1 over 1, which comes from opposite over adjacent. What we have to pay attention is whether the tangent function is positive or negative, because we know that the range of tangent function is from minus pi over 2 to pi over 2. That is first or fourth quadrant. In the first quadrant, tangent value is positive because that is y over x, which is plus over plus. In the fourth quadrant, tangent is negative because tangent is defined as y, which is negative over x positive. So minus over plus is minus. So when we think about theta, theta should be located in the fourth quadrant. The next thing we have to think about is the reference triangle. This time, opposite and adjacent are 1. So it is 1, 1, square root of 2, which is 45, 45, 90-degree triangle. So pi over 4, here is the reference angle of theta. In this case, we identified the reference angle of theta, that is pi over 4. So this angle is pi over 4, but that angle should range between minus pi over 2 to pi over 2. So this angle, the actual angle is minus pi over 4. Tangent of minus pi over 4 equals minus 1. So we can say that tangent inverse of minus 1 equals minus pi over 4. Second problem is tangent inverse of 0. Tangent inverse of 0 equals the angle theta, which is in minus pi over 2 to pi over 2. We can interpret that as tangent of theta equals 0. Since the value is 0, we cannot draw the triangle. Instead of that, we have to think about the original tangent function's graph from minus pi over 2 to pi over 2. This is the graph of tangent that passed the origin, means tangent of 0 equals 0. So we can conclude that theta, the angle theta equals 0. And so tangent inverse of 0 equals 0. The next problem is tangent inverse of square root of 3. Let's follow the definition. Tangent inverse of square root of 3 is the angle theta whose tangent value becomes square root of 3. The angle should stay between minus pi over 2 and pi over 2. So when we reinterpret that, tangent of theta equals square root of 3, which we can rewrite that as square root of 3 over 1. That came from opposite over adjacent. And then we have to look at the value and determine whether that is positive or negative. That is positive value. So when we think about the range of tangents, we can say that theta is located in the first quadrant because tangent is positive in the first quadrant and negative in the fourth quadrant. Any angle in the first quadrant is an acute angle. So once we identified the reference triangle and reference angle, that reference angle will be identical to the angle theta. Opposite of theta is square root of 3. Adjacent of theta is 1. And that is 30, 60, 90 degree triangle. So 1 is adjacent to pi over 3. So theta is pi over 3 because tangent of pi over 3 is square root of 3. Opposite square root of 3 over 1 is square root of 3. And we make sure that is in the interval minus pi over 2 to pi over 2. So the conclusion is tangent inverse of square root of 3 equals pi over 3. So pi over 3 is the final answer. Use a calculator in radian mode to find an approximate value of the expression correct to 5 decimal places if it is defined. The first problem is tangent inverse of 11. Fortunately, TI-30XA calculator has tangent function key, so the answer is instant. You press 11 and then second and tangent for tangent inverse. Make sure that that is in the radian mode. Currently, that is in the radian mode. Otherwise, you have to use DRG button to change it, the mode. 11 and tangent. No, 11 and inverse tangent. So that becomes 1.48014 because 6 is greater than 5. The second question is tangent inverse of minus 21. That is 21, and then you have to switch the sign by pressing this button, and then second tangent. Let's do that. 21, then switch the sign, second tangent. So minus 1.52321 because the following number is 3, which is less than 5. Tangent function has similar inverse properties. Tangent inverse of tangent of x equals x. This time x is an angle. When we define the tangent function, we limited our angle range between minus pi over 2 to pi over 2. So there is a condition only if x is between minus pi over 2 and pi over 2. Otherwise, we have to rearrange the angle so that both will have the same tangent function value, but angle is in the range of minus pi over 2 and pi over 2. Tangent inverse of x equals x for any x. This time, the range of tangent is from minus infinity to infinity. So this can be any real number. Let's do some examples. Find the exact value of the expression if it is defined. We want to think about tangent inverse of tangent of minus pi over 6. Let's follow the definition. Tangent inverse of tangent of minus pi over 6 is the angle between minus pi over 2 and pi over 2. That implies tangent of theta equals tangent of minus pi over 6. So what's important here is as long as this angle belongs to this interval, everything is okay. Let's locate the angle. This is 0. This is minus pi over 2. This is pi over 2. We want to compare it. So minus pi over, this is minus 3 pi over 6. So minus pi over 6 is between 0 and minus 3 pi over 6. So that's in the fourth quadrant. And this is minus pi over 6. So that's in the range of inverse tangent function. So there is no problem. And theta becomes minus pi over 6. Second question is tangent inverse of tangent of 2 pi over 3. We again follow the definition. Tangent inverse of tangent of 2 pi over 3. That is the angle between minus pi over 2 to pi over 2. What we know is that means tangent of theta equals tangent of 2 pi over 3. If 2 pi over 3 belongs to the range of tangent, which is first and fourth quadrant, then there is no problem. However, if that is not in that range, then we have to relocate the angle, and we have to find another angle whose tangent value is the same as tangent of 2 pi over 3. and the angle belongs to the region minus pi over 2 to pi over 2. We have a 2 pi over 3. Here is pi. That is 3 pi over 3. This is little less than pi. So the angle is located in the second quadrant. This is 2 pi over 3. In that case, that is not in the range of tangent inverse. So we have to look for the angle between minus pi over 2 to pi over 2. The way we do that is by considering the reference angle first. So we think about the difference between this number and this number, which is pi over 3. Next thing we have to consider is the sign of tangent in the second quadrant. If you think about the tangent is y over x. Y is positive in the second quadrant and x is negative, so tangent value is negative. And we also know that tangent is negative in the fourth quadrant. So if we think about another angle, theta, in the fourth quadrant, whose reference angle is pi over 3, then that is the angle whose tangent value is the same as tangent of 2 pi over 3. The reference angle was pi over 3, so this angle is minus pi over 3 because angle ranges between minus pi over 2 to pi over 2. So what we are getting here is tangent of minus pi over 3 equals tangent of 2 pi over 3. That means tangent inverse of tangent of 2 pi over 3 equals minus pi over 3. So if I go a little more details, then when we think about actual tangent value, this was tangent of reference angle of that angle plus or minus. In the second quadrant, tangent is minus, so that is minus pi tangent of pi over 3. In this case, we do the same thing. The reference angle of minus pi over 3 is a tangent of pi over 3, but tangent value in the fourth quadrant is negative, so we put negative. So though the two values are the same, but this angle is in the range of tangent inverse, so that became a answer. Next problem is tangent inverse of 9 over 8. What we want to do first is we want to take care of this part. Tangent inverse of 9/8 inverse tangent, so that is the angle between minus pi over 2 to pi over 2. That implies tangent of theta equals 9/8. Convenient aspect of tangent function is tangent function's range is any number. So we don't have to be careful about this type of the answer question. Tangent inverse of 9/8 can be rewritten as tangent of theta. We just did the substitution because tangent inverse of 9/8 is written here. That was theta. And the second line tangent of theta was 9/8. So the final answer is 9/8. Find the exact value of the expression if it is defined. First one is tangent of sine inverse of 1/2. In this kind of problem, we are using geometric method to get tangent function. Sine inverse of 1/2 equals theta. We think about the graph of sine function, and we limited ourselves to the region where sine was 1:1. That was minus pi over 2 to pi over 2. And then sine of theta equals 1/2. So that's greater than 0. So we can say that the angle is located in the first quadrant. And 1 is opposite and 2 is hypotenuse. So this is 1 and this is 2. And we know that this one is square root of 3 because hypotenuse squared minus 1, the adjacent squared, and then take a square root, that is square root of 3. So by thinking about this triangle, we can evaluate tangent value. Tangent of sine inverse of 1/2 equals this time opposite over adjacent. 1 is opposite and adjacent is square root of 3. So that is 1 over square root of 3. In this particular case, we can use the spatial triangle also. So by looking at sine of theta equals 1/2, we can relate that with 30, 60, 90 degree triangle, 1 to square root of 3. This time it says opposite is 1 So the angle involved to there is pi over 6, and adjacent is square root of 3. So we can say that sine of pi over 6 equals 1 over 2. And then we can say tangent of sine inverse of 1 over 2 equals tangent of pi over 6. Because this is equivalent to, say, sine inverse of 1/2 equals pi over 6. So you can just think about tangent of pi over 6, then opposite over adjacent, which is 1 over square root of 3. However, the method I used here is more general. Even though you don't know the actual angle, you still can get the tangent value. So this is a better method you can use. The next problem is cosine of sine inverse of 0. Let's consider sine inverse of 0. Then that equals theta. Then sine of theta equals 0. We already know the angle belongs to minus pi over 2 and pi over 2. Sine theta equals 0. The triangle cannot be involved, but we know that the sine function always, sine of x passes the origin. So sine of 0 equals 0. So theta equals 0. We will just use this particular property. Then cosine of sine inverse of 0 equals cosine of 0 because theta is 0. Cosine of 0 equals 1. This time we think about the graph of cosine. So cosine of 0 equals 1, so that is 1. Sine of tangent inverse of minus square root of 3. Tangent inverse of minus square root of 3 equals theta. We already know that theta must belong to minus pi over 2 to pi over 2. I said minus pi over 2 and pi over 2 are not included in the interval because those are vertical asymptotes. From there, we can say that tangent of theta is minus square root of 3 over 1 from here. Then that is minus opposite over adjacent. And that has minus, so that is negative. If we visualize the circumstance, the range of tangent inverse is from minus pi over 2 to pi over 2. Tangent value is negative in the first quadrant, so we can draw the graph here. If you look at the problem, then not only tangent, but also sine is involved. So it is good to think about the sine value in the fourth quadrant. Y values in the fourth quadrant is negative, so sine is negative. That means the final answer will be a negative value. Let's forget the sine. Let's just think about the reference triangle. Opposite is square root of 3. And adjacent is 1. And then hypotenuse is square root of 3 plus 1. Square root of 3 squared is 3, so 3, 1. Square root of 4, which is 2. Indeed, that is 30, 60, 90 degree triangle, so it becomes 1 to square root of 3, but we don't want to think about the particular angle. Let's say this is theta. Then sine of tangent inverse of minus square root of 3 can be written as sine of theta. Theta is an acute angle, so we have to put minus in front of that. Then that is minus opposite over hypotenuse. So that is minus opposite is square root of 3 and hypotenuse is 2. So final answer is minus square root of 3 over 2. Rewrite the expression as an algebraic expression in X. Problems become a little bit abstract, but the way we solve the problem will be exactly the same. Sine of tangent inverse of X. We think about tangent inverse of X first. Tangent inverse of X equals theta between minus pi over 2 and pi over 2. So we can say that tangent of theta equals x. We can rewrite that as x over 1. We don't know whether x is positive or negative, but it'll carry all the way to the final answer. So that is from opposite over adjacent. So sine of tangent inverse of x can be rewritten as sine of theta, because tangent of x is written here. So instead of tangent inverse of x, we will write theta here. Then by the definition of sine function, that is opposite over hypotenuse. Let's draw the triangle. This is theta, this is opposite, and this is adjacent, and this is hypotenuse. Opposite is x, and adjacent is 1, and hypotenuse by Pythagorean formula, that becomes x square root of x squared plus 1 squared, which is 1. So opposite is x, and the hypotenuse is square root of x squared plus 1. Second question is tangent of sine inverse of x. Let's consider sine inverse of x, then that equals theta, the angle between minus pi over 2 to pi over 2. And then sine of theta equals x, then that is x over 1. We want to apply the definition, that is opposite over hypotenuse. Now, we rewrite tangent of sine inverse of x as tangent of theta. Again, sine of x is here, so instead of sine inverse of x is here, so instead of sine inverse, we just wrote theta because that equals theta. That is opposite over adjacent. We already know the opposite, but we don't know the adjacent, so we have to draw the triangle. This is theta, this is opposite, this is adjacent, this is hypotenuse. By looking at this, opposite is x and hypotenuse is 1. We know that x squared plus 1 squared equals x squared plus adjacent squared equals 1 squared. So adjacent squared equals 1 minus x squared. So adjacent is square root of 1 minus x squared. We took square root on both sides, and that is positive because we are thinking about the length of the side length. So opposite is x and adjacent is square root of 1 minus x squared. This is the final answer. If x was positive, then the final answer will be positive, but if x was negative, then final answer is negative. But we don't change, put plus or minus because x itself has a property of positivity or negativity. Cosine of tangent inverse of x. Let's start with tangent inverse of x equals theta. Then tangent of theta equals x, and that can be written as x over 1. That is opposite over adjacent. We can rewrite cosine of tangent inverse of x as cosine of theta. Again, we are applying this. Then we have to figure out cosine of theta. Cosine of theta is adjacent over hypotenuse. We have a right triangle. Opposite is x and adjacent is 1. So hypotenuse is square root of opposite squared, which is x squared, and adjacent squared, which is 1 squared, which is 1. So hypotenuse is square root of x squared plus 1. So adjacent is 1 and hypotenuse is square root of x squared plus 1, which is 1 over square root of x squared plus 1.